Assalamu alaikum. Can you hear me?
Ji, Assalamu alaikum. I can hear you.
Hopefully you have revised some work. You have a test tomorrow, right?
Yes, of the base units.
Only. What about uncertainty?
Base units and uncertainty, both of them. The base
Yes.
unit was fine, but the uncertainty is also a bit troublesome.
That is a topic which many people get trouble. So let's try some questions on chapter 2. Have you learned the formulas? I had shared the formulas also.
Yes, there were like 7 formulas, right?
Sorry.
7 of them.
Yes. So do you have the past paper book with you?
No, I don't have it right now. I can get it.
You can, if you get it, so we can save this will save your time, because once we are doing it, you can do work on your book. It will give you more practice, plus it will be side by side, your work will be done. I'm starting winter 2017 221.
I got it. Should I open the base unit chapter?
I think it should be in the measurement chapter. I don't know about the book. Maybe they have combined the 2 chapters, or maybe what is the name of the second chapter in this book?
It is kinematics topic 2. And in the first topic, they've given.
Then you're right. You can do it directly here. One end of a wire is connected to, this is, if you find this question, November 2017, paper 2, question number 1.
I found it.
Good. So we start the question. One end of a wire is connected to a fixed point. A load is attached to the other end so that the wire hangs vertically. The diameter of the wire and the load F are measured as D is equal to this, F is equal to this. For the measurement of the diameter of the wire, the name of a suitable measuring instrument.
It will be a micrometer screw gauge.
Micrometer or vernier caliper, the uncertainty is 0.02 millimeter. So micrometer looks fine. Now we have given the name.
So the second answer will be like the reducing the parallax error by viewing it parallel.
How random error may be reduced when using the instrument? No, actually the famous answer comes when you're using a micrometer screw gauge. You have to take many readings along the length of the wire and spirally on one position of the wire, and then you have to average them. So actually this question always comes with the idea, if this is the wire, you take readings from different points. even on one point, you move around the wire and you take 2-3 readings, and then you move through the length of the wire and you take readings and you average them. So this is the answer for the second one. The stress in the wire is calculated by using this expression. Show that value of alpha is this. So we can say we have force and diameter. Force is 25 and diameter is 0.4 millimeter. So we can make the data. Force is 25 Newton, ready to use, but diameter is 0.4 millimeter. So I'm taking it in. So other values you already know. So put the formula and let me know the answer.
It is coming as 198.9.
So sig fig, 3 sig fig he's using, but he's giving the answer 1.98. He's asking to show something is coming wrong because it's a show that question. Can you recheck the calculation?
Now I'm getting the same answer. First, I think I didn't convert it from millimeter to meter.
Okay, good. Now determine the percentage uncertainty in sigma. Whenever you write a formula for uncertainty, you have to remember that it's a ratio. So you will write deba sigma like this upon sigma. Then you write plus minus. You have to ignore pi. You have to ignore 4 because they are constants. Sigma f upon f plus 2 sigma d upon d. He's asking for percentage, so I put a percentage sign here into 100.
The first value will be the percentage uncertainty of it.
Hmm?
The
Sorry?
like the values which are in the brackets, they will be like the 0.02 and the 0.5.
The numerator is always the smaller number. It's 0.5 upon 25. When you put them, it will be 0.5 upon 25 plus 0.02 upon 0.4.
So as there was a square, so this whole thing will be multiplied by 2, the D1.
Sorry, I have written 2 in the above bracket, but forgot to write it in the second. Correct. It has to be 2 into
So
2.
I can first solve the bracket and then multiply it by 2.
All right, you can do that, but it's very simple. It will become 0.04 upon 4, 0.4. So if you want, you can do that.
It is coming as 12%.
Okay. I think it looks fine, but after that, use the information in B part 1 and your answer in B part 2 to determine the value of sigma with its absolute uncertainty to an appropriate number of sig fig. How many sig fig should be included in an uncertainty? Have you revised that? Uncertainty, how many significant figures should be there in uncertainty?
3 significant figures.
Remember that? Remember that uncertainty is always given correct to one significant figure. Whenever you write uncertainty answer, remember uncertainty must be given correct to one sig fig. Use the information in B1 and B2. So we have sigma in our hand. Now let's solve it. We have a percentage uncertainty. Percentage is equal to sigma upon sigma into 100. This is the formula. I have percentage, you got for me 12. I need to find the uncertainty in sigma. The absolute value we had proved 1.99 into 10 is to power 8. Now, rearrange it. I have to copy down this. And you have to solve this value for me.
It is coming as 2.4 into 10 power 7.
Good. It's coming 2.4 into 10 is to power 7. Make it 0.2. Deliberately ignore 4 and make it 8. When you write uncertainty, you always should try to keep the same power. Otherwise, it would be difficult to write in the common format style So I deliberately go against a common rule that 2.4 is right, but I made it 0.2. Now, why I did that? Now I can write 1.99, and here I write 0.2, correct to 1 sec fig. I make a bracket and I wrote 1 10 power 8. So I can take 10 power 8 common. Write this style of writing specially.
I wrote it.
Now let's try this question. It will be a mix.
So
It
this
shows, sorry,
precision is not part of this chapter.
it's same chapter, June 7. I think in your book, it's a combined chapter, June 17, 221. So first look
Uh,
for this question.
because in the book ahead of this part, it gives like state what is meant by precision and precision of the screw gauge.
Sorry, I couldn't hear you.
Can you hear me now?
Yes.
Yes, because in the book it is given like state what is meant by precision, and then it is asking for the precision of some instruments.
Uh, the question we were doing just right now.
Yes.
No, there should be. I think the question is completed. Are you sure there is another part after it?
I think so.
No, I think question is completed. Precision can't come there because that question was totally on uncertainty. Anyways, I don't have that part, and you can check it later. Precision, you know the concept, right? It is the concept of values which are close together. Can you find this question, June 17, 221?
No, this one is not here. Then 2015 comes.
It's not there.
No, this one. Maybe it's some other one. Like it's not in uncertainty.
Maybe, okay, fine. Let's do it on the screen with me. State two SI base units other than kg, meter, and second. I think this is one of the most common questions that come from paper one. You know, there are 7 base quantities. There are 7 base quantities. He has mentioned kg, meter, and second. So still I have 4 left. So I can refer for
Yeah,
current,
ampere and
I can
Kelvin.
refer, and what about any other temperature? Should I refer to temperature?
Yeah, yes, Kelvin for temperature.
Okay, good. He's not asking for physical quantity. I wrote it for the reference. Now determine the SI base units of resistivity. I write the formula for you so you can help me to get the unit because it's asking for derivation. I make resistivity the subject. This is the case. Now, what is the unit of resistance? We can say, what is the formula for resistance? He's asking for base unit.
V over I.
Resistance is, yes, V over I. So this is V over I, it is area, it is length. Now, we reach up to here. V and I are the base units. I is base. What about V? Is V the a base quantity?
No, V
Voltage.
is not base quantity.
Okay. So I'm here. Now I want to adjust it because voltage is not a base quantity. So I need help in tackling voltage. So how should I tackle voltage now? He's asking for base unit. So can I convert? What about voltage? if I work separately, voltage is work done per unit charge. What is work done in unit? It's joule upon coulomb. Voltage is volt. Voltage is volt and it is joule per coulomb. Can you recall for me what is joule? Is it Newton meter?
It is
Is it?
Newton meter.
What about coulomb? Is it ampere into second?
Ampere second. Yes. So we can also work these out, right? Like we don't need to remember them.
Obviously, you just have to remember the formula. Some of them should be remembered. Joule, volt, they come so oftenly, so it's better to learn them. Otherwise, okay, how I can replace Newton? Can I write it kg ms minus 2 into meter upon ampere into second?
Yes.
Then kg m square s minus 2 upon ampere into second. I have separately solved voltage. Now, how to manage resistivity here? Voltage is kg m square s minus 2 ampere into second. This is for voltage. What about area? Area is meter square upon current is ampere and length is meter. Can I cancel meter with meter?
Yes. The square will be finished.
Okay. And after that, 1 meter is still left up.
Yes. So and A will be cancelled.
No, the above A is in denominator. You can't cut denominator with numerator.
Okay.
So it will be kg. I'm writing m cube. How come it gets m cube?
Meter square into meter.
There's a denominator a into second. So I will shift it down. It will be a square it will be a square into second. Can we further simplify it? Can we bring them up?
So we put the AS down and got the A square S.
Yes, definitely. It's a fraction with fraction. What about second now? Can you help me? What will happen to second?
It will be -1. -3.
Yes, now you got it. It's not -1, it will be -3. So we could recall the basic, the most common question from this chapter, which is the interpretation of base units. You just have to remember all the formulas for that. A wire of cross-sectional area 1.5 millimeter square and length 2.5 meter has a resistance this. Calculate the resistivity in this. The letter N stands for nano. You know nano, 10 power?
-9.
-9. Good. So now solve for that. We can say that R is equal to rho. He's playing with units actually, na? So if you make the subject R A upon L. If you make it like this. Now, what is the resistance? Resistance is fine. I don't need any change. But what about area? 1.5 millimeter square. You know, 1 meter is equal to 1000 millimeter. And there is a square on it. 1000 means 10 to the power 3. And what about square? If I square it, then will it become 10 power
6.
6? Okay. Now it means I will write carefully, see 1.5 into 10 is to power minus 6. Why minus? Because you are coming from millimeter to meter. The length is 2.5 meter. Okay. So let's get this answer.
It is coming as 1.8 into 10 power minus 7 meter.
1.8 10 power
Minus 7.
minus 7 meter. I'm sorry, it's the unit is unit would be I would be getting
meter.
ohm meter, but he
Ohm
wants to convert it to nano, so I have to multiply it. Multiply this system.
With only 9 or minus 9?
No, it's a rule in basic mathematics. Now you are going from a bigger unit to smaller unit. So you will multiply now. Smaller to bigger, you divide. Bigger to smaller, you multiply.
Okay, we have it in meters, so we are just making it into a smaller unit. It is coming as 180 now.
It's too high for a wire. 180 is looking to be a high number. You have to check your calculation because 180 is looking to be a big number. Oh, it's my mistake actually. Sorry. It is 0.03. I wrote 0.3. So it is 0.03. You have to make a correction. So the power, only the power will change. And we can see it become, you have to change the power.
Now it's coming as 18.
Right. State what is meant by precision. Can you recall for me what is precision? Is the extent to which values are close to each other.
It was like the range of it.
You can say the range of it. So what is meant by precision? It is the measure of the extent to which values are close to each other. In simple terms, how much values vary in range. So if values are very close, you will say that it is precise. Explain why the precision in the value of the resistivity is improved by using a micrometer screw gauge rather than a meter rule to measure the diameter of the wire. It's a basic theory question because micrometer has a smaller least count. You can say micrometer can read to a much smaller reading. So micrometer reading would be more precise.
It is 0.01 millimeter, right? For the micrometer.
It's actually its least count is even smaller than 0.1. 1 millimeter is for a meter rule, and 0.1 for I think vernier caliper, and 0.01 is for micrometer. June 17, 211.
I have this one in
Good.
my book.
Determine the SI base unit of stress. So first, as I said, for these questions, you have to remember the formula.
Force over
Force
area.
area. Force is Newton, area is meter square. You make a partition and you write sigma S for stress. What is Newton? Newton is kg ms minus 2 upon meter square. So if I call meter square up,
So it will be -1 kg and -1.
minus 1 s minus 2. A beam PQ is clamped so that the beam is horizontal. A mass M of 500 gram is hung from NQ and the beam bends slightly as illustrated. A slight bending has occurred. The length of the beam from the edge of the clamp R to NQ is 60 centimeter. The width B of the beam is 30 millimeter and the thickness of the beam is 5 millimeter. The material of the beam has Young modulus E. The mass M is made to oscillate vertically. Time period of the oscillation is 0.58. The period T is given by the expression. Determine E in GPa. So I think they have given us some info. So what should I do? I should first try to make E the subject because it's a 4ml cubed. Should I square on both sides for removing the square?
Yes, the T will become squared.
4 pi square.
Even the pi will be squared.
Obviously, because pi is not inside the root. Everything
Oh.
outside is squared. This is the first step. you have to make E the subject. So I will move E here. And I will say 4 into 4, 16 pi square m LQ upon T square B BQ. Now you have to see the data. Mass is 500 gram. He's playing with the units again. 500 upon 1000. I have to use that. And 60 centimeter the length. So 60 upon 100. The width is 30 millimeter. अच्छा, 30 millimeter. And the thickness D is 5 millimeter. So 5 upon. We have a lot of material data available. T is 0.58 second. And you have to determine capital E. Now you have to put all the data carefully and find E. Let me know when you get the answer.
It is coming in 1.65 at power 10. Pascals, the answer.
Sorry, I missed it, but how much you got?
1.35 into 10 power 10 Pascal.
He says G, gigapascal. So if it's giga, Should I divide by 10 power 9? Oh, sorry, multiply by 9.
Giga is 10 power 9.
Giga is 10 power 9, no? So how should I convert it?
By multiplying it with that value of giga. 10 power 9.
No, Pascal to gigapascal.
Okay. So we'll divide it then.
Just like millimeter to meter. Yes.
— 13.5 is the answer which is coming.
Sorry.
13.5 gigapascal.
That looks fine. Now you have to move this to this one. The quantities used to determine E should be measured with accuracy and with precision. Explain the difference between accuracy and precision. Accuracy is the extent to which values are close to the actual true value. While accuracy is the extent to which values are close to the actual value. What about precision? As we discussed, it's a measure of the range of values. How much values are scattered? In a particular experiment, the quantities L and T are measured with the same percentage uncertainty. State and explain which of these two quantities contributes more to the uncertainty in the value of E. This is a tricky part. He says uncertainty percentage wise is the same in L and T. Same percentage. But who will affect the E more? T has a square, L has a cube. T has a square, L has a cube. In terms of uncertainty, T will be multiplied by 2 and L will be multiplied by 3. L is in the, you can see now the difference is in the power. So who will be more contributing? Square function or cube function?
The cube will be contributing more.
Very good. So I will tell examiner that there is a T square and there's a L cube. L cube will be more contributing. Look for this question. It's June 16, 2023.
I have found it.
Good. It looks to be a pure theory question. Systematic error. What is a systematic error? Systematic error is where the error is constant in magnitude and direction. It's a fixed number. Random error is where the error varies. So what was the definition? error which is constant in magnitude and direction is called systematic error. What is a random error? The error which varies, maybe it's 2 times, maybe 4 times, maybe half. It takes different values. It is called random error. It's a type of scatterness. Distinguish between, we already have discussed precision. Precision means how close your answers are together mutually. And accuracy is the extent to which values are close to the true value. Now we have June 2016 211. Look for this question.
I found it.
Okay, that's good. Make estimates the mass in kg of a wooden meter rule. This is estimation. Estimation, sometimes people find it very difficult because sometimes the number comes directly up just like from nowhere. But anyways, there is always an intelligence guess. Wooden meter rule. You must have used it. So you have to guess that how much a wooden meter rule will be weighing. It's not heavy actually. You can think in
Half
gram
kg,
first.
like 250 gram maybe, like
Half kg,
100.
half kg looks to be a bit higher side, but half kg is ruler is very light. You can pick it in your hand.
Like 150 grams, 100 grams. It must not be more than that.
100 gram is fine. If I say 100 gram, then it is okay, better. The volume of a cricket ball or a tennis ball. Now, this is a bit challenging question because cricket ball, you have seen it many times, but it's not so simple to get its volume until you assume that the cricket ball is a sphere and the formula for a sphere is 4/3 pi r cube.
In diameter, it will be like less than half a meter. It's very small.
Even meter is too big. I think it's not even half meter. I think it's even less than that.
Like 20, 30 centimeters, 40 centimeters.
You can say like that. I don't actually remember I don't know the actual radius, but I think you're right because 1 meter is 100 centimeter. So if we can take 25 centimeter, 30 centimeter. We can try that, how much volume it gives us. Generally, examiners keep a very good range for such questions. So you just have to make some intelligent guess. How much radius we are taking?
40 centimeters.
Okay, let's try that.
It is coming like 0.107 now.
In meter cube, right? Or centimeter cube?
Centimeter cube. In meter cube. Now I'll convert, like multiply this by
We
100.
no. We took 40 centimeter, right? So you put 40 or you put 40 upon 100?
I took 0.4.
No. He's asking the answer in cm cube, no? So you can keep it like that.
Now it's giving a very large number, like 268,000.
That looks to be a bit too high.
We can just take
you have to reimagine that let me imagine also, you should also imagine the radius of a cricket ball. I think 40 cm is also on a higher side. Think about any other number, like we can say 10 centimeter. You can imagine from a meter rule. You have seen meter rule and you have seen centimeters. Now imagine the ball, and I think you can reach the good value.
Like 7, 8.
Okay, try that.
Now also it's too high. It's coming as 1436.
Obviously, in centimeter, it would be how much radius we took now in our second try. In your second try.
7 centimeter.
Okay, then how much answer we are getting?
14.
Okay, 1480. Now, a metal wire of length L has a circular cross section of diameter D. Volume of the wire is given by the expression pi d square L upon 4. The diameter, length, and mass M are measured to determine the density of the metal of the wire. The measured values are like this. Calculate the density of the metal with its absolute uncertainty. So you should first get the formula down.
The range for the previous question was coming 50 to 300
Sorry. Huh?
cm cube. It was 50 to 300 cm cube at the back.
Acha, 52.
300.
And our answer is crossing the range.
Ours is 1436.
So we are getting 1500.
Yes, almost.
It means the radius is even smaller than that. We should take 5 centimeter then. 5 or 4 centimeter. So this is the formula. You have to put D 0.38 divided by 1000, and L is 25 divided by 100. He is given unit conversion in every time. 0.225 divided by 1000. You need to put them all, and you need to find what I did. It is volume. First, we should get the volume. The formula is for volume. Then we will use density is equal to mass upon volume. Then you find density. First, help me to find the volume.
It's coming as 7.5.
Sorry, I lost your sound. Sorry.
7.5 into 10 power minus 5.
For volume.
Yes, for the volume.
So put it in the formula to get density, mass upon volume.
It is coming as 3, the answer.
You are getting 3.
Yes.
So I made the working and you have to put the values now. I have delta m upon m, but I don't have delta v upon v. You need to get delta v upon v also for me. First, you get delta v upon v.
I think I made a mistake in finding the density.
Okay. So
I
anyway,
I didn't put the squares.
oh, because this calculation is going too long. I have another idea that we can modify the formula because it will take a long way to complete this. Even we have the data and you have just first modify the formula and then we can use it. We have your volume is right.
Now it's coming fine. 2.835 into 10 power minus 8, the volume.
Okay. I have modified the formula to save space. You can see this working. I have all the data in my hand, and this can help me to get the density directly. You can confirm the value from this equation also.
Now I got the density, but using this old one, it's 7940.
Okay. This is the formula. Point 0.01. Try to complete this calculation quickly.
It is coming as 7.9%. 0.5%, sorry.
No, you're not required to get the percentage. You're required to get, you have to multiply with density to get a whole exact number actually.
For the exact number, it is 484.9.
Sorry, for
484.9, the exact number.
good. So you're getting 480, right?
485.
Okay, then make it 500. So that's over for today. We have completed this, and you should always, as usual, you should try to do some more questions. You have to remember in spacing, because these questions are not difficult, but they take a lot of space, and sometimes you write in full and you lost the space. So before you finish the day, you should revise the definitions. We are missing some definitions. I think you should revise them. What about vectors? Has he done vector in this chapter with you?
No, the test is not on vectors. I checked.
Okay. If you're sure about it, then let it go. Hope it goes fine. Allah Hafiz.
Allah Hafiz. Allah Hafiz.